All right, gang, welcome to my channel and welcome to this video. I want to talk to you about how I quote unquote discovered a high proper motion star. In fact, it's a dwarf star. As you probably know, most stars in their lives as dwarfs. Some end up exploding into nova, and some that are really big go into supernovas, and those that are really, really big eventually turn into either neutron stars or black holes. But this is the same technique that I've used to confirm that I imaged Pluto as well as the asteroid Vesta. So if you look over here, I'm on astronomy.net. This is a great site, and if you're familiar at all with plate solving, many astrophotography imaging programs use plate solving, and this is one of the websites that is used to do that. And if you don't use an astrophotography program to do so, you can always just come to this website and do so. Now, looking on here, you can take a JPEG or a FITS file, and if you're not quite sure what part of the sky you're looking at, or if you want to verify that you see something in your image that maybe is not supposed to be there. In other words, it's something with high proper motion, an asteroid, maybe Pluto, even a satellite. You could even, if you hadn't figured it out, that's a satellite, you could come here and use this website to do so. I'm not going to click the button here, the upload tab, because I'm not sure if I could get back to this. But if you go to the upload page by clicking here, you simply upload your JPEG or upload your FITS file, and then this thing will crunch on it for a little while, and then this page pops up and it'll say success over here, and it'll show you some of the known stars, 46 Leo, which tells me we're somewhere near the constellation Leo. Then you can come over here and view your image relative to a worldwide star map, and you get different things over here. The one I always go to is Worldwide Telescope. So if we click that, we end up coming over to a page that looks like this. Now I'm going to zoom out, and this gray area here is the photograph. I hope it shows up in this video, but this gray area here is the JPEG that I uploaded, and I could have uploaded different file formats, but JPEG works fine. And then you see this crossfade here, image crossfade. If I run this slider down, my image disappears in the background map, and there's several selections I can choose from to put up this map. And it's really not a map. This is real world imagery from a various number of telescopes. It's all been stitched together to form a worldwide, if you will, or a sphere-wide map of the stars. But as I slide this crossfade slider over, my image is the one that becomes 100% opaque here. And I can go over here and look at this, say for example, this string of stars, and ask myself, well, is one of them an asteroid that I intended to image? So as I turn off my image by sliding this slider over here, and then look at the background stars, sure enough, my stars match the stars of the map. And for other, there's another term for this, although this isn't quite the technique, and it's called blinking, which is how Clyde Tombaugh discovered Pluto, by blinking, if you will, with glass plates. And there's several programs out there, PixInsight, for example, that blink. You could use a simple photo viewer in Windows to click back and forth, back and forth, back and forth between two different images to blink. But my technique to confirm that I had indeed captured Pluto was to come here, upload the chunk of sky, my image where I thought Pluto was, and literally blink this thing back and forth until I saw something that was there on my image that's not there on their map or their set of images, or something that had moved. So on this particular night, if you will, and it was about a month ago or so, I've just had the chance today to kind of mess around with this. I was trying to image the asteroid 29 Amphitrite, if that's how you pronounce it. So zooming out, I've already been on here before a couple of weeks ago, but today I had time to jump back into it. I kind of zoomed out and I looked for something that was very apparent, like obvious movement. And it's not a very dim asteroid, relatively speaking. In fact, I think it's the third brightest out there, maybe the third or fourth. So, and certainly my scope would have picked it up. But then, I didn't find it immediately and had to move on to some other projects and whatnot. But today we've got I won't call it a blizzard, but it's a heck of a snowstorm. So there's not much to do except toy around with this. So I thought, well, let me give it a closer look. So I went, if you will, sector by sector, looking here for things that looked different, things that appeared to have some pretty good proper motion. And I went back and forth until I got to an area here, and I hope I haven't lost it. Let me see if I can find it. Let me zoom out some, come back in here. And it's going to be somewhere in this area. Yep. Let me just take a look. And I came into this area right here, did my little blinking trick / slider, and I saw this right here. So that's my image, just to the upper right of the crosshairs. In fact, I'll put it even closer to the crosshairs so you can reference it. So that's my image. Notice the slider's all the way to the right. And then if I go to their image, there's a little bit of movement there of that star. And needless to say, it got my attention. Now you'll notice, if you look, for example, right here, look at these two stars right here, and that's in my image. If I look to their image, there appears to be a little bit of movement, but really what's happening is I've got some aberration from my mirror and the telescope and the lenses and the camera, and maybe some processing, and a little bit of wind blew my setup around a little bit while I was imaging, versus the who knows $1 million telescope that took this picture. So you're going to see some variations in here, but what's important to note that if there's going to be any movement, let's say in this particular star, then I should see pretty much the same amount of movement in all the stars, or the same amount of spherical or coma, aberration, anything along those lines. But if you come back and look at this one and then pay attention to these two, let me move that crosshair out of the way. So this is our apparently moving object, and these are two nearby stars. Watch the three of them, and you'll see that it's just that upper one that appears to have movement. And in fact, if you look at that very, very dim one there, let me get my mouse out of the way because I know it's got a green halo around it. You'll see there's a very dim star underneath this brighter one we're talking about. Notice it doesn't even move. It's still there in my image, and I hope that shows up in the video. Although my image didn't capture it as well as whatever telescope took this. Kit Peak Observatory does a lot of these things, I know. And I had a lot of light pollution too as well. You can see how even the galaxy changes. It's much better prominent in this image and then versus mine. But the point is, I can tell it's a galaxy, and I can tell it hasn't moved much. But this thing has moved quite a bit. So I set out this afternoon to find out, well, what is that star? So I started by going to some of the various online star maps that you can find, and finding this location on those maps and clicking on some of these brighter stars just to kind of figure out, okay, where am I at? I know I'm in Leo, but where in Leo am I? And I ended up running across Stellarium. Now, Stellarium, if you're familiar with that application, great program. Well, apparently they have, I didn't know this, they've got a website where you can use some of the basic Stellarium functions as you can the app. So I called that up based on searching for a couple of these objects here. If we zoom out, I think it was 46 Leo, somewhere in here. That may be it right there. Anyway, I came in here and I said, well, there's the star. If you click on it, there's the name of it. But notice where Stellarium, remember Stellarium does an overlay. So if I click on a star, Stellarium doesn't know that I'm clicking on the actual star in the image. There's a layer, and the bottom layer is the imagery, and the top layer are these application generated objects, these white dots, if you will, which is why if I click here, there's no response. These are definitely stars, but I'm not getting a response. But if I click here, I get a response because Stellarium knows I clicked on the object it generated, and it overlaid on the imagery. So back to our star in question, or whatever this object is, I noticed that the imagery and where Stellarium thinks this object lies does not match, which is pretty interesting. That tells me that whoever built the database that Stellarium's getting its information from used data that's a different source than the data that would be generated from the imagery in the background. Notice these all white dots that I'm clicking on. In other words, the upper layers. Look, that one even has a little bit of offset. This one doesn't. This one doesn't. The galaxy's still there. Of course, makes sense. This white dot is still on top of that star that was imaged in the background. But this one's very obvious. There's a big delta there. Excuse me. Which again led me to believe that I've got something that's moving, and it's apparently a star by what you can tell right here. And of course, when you click on something, you get the name. So I went over here and said, well, what's the name of this? And I learned that Gaia, if that's how you pronounce it, is a European Space Agency satellite that was launched, and its purpose was to image stars multiple times and look for proper motion, measure exact distances using parallax, and if able, go back and look at them multiple times and determine and look for that movement. And if they see movement, if it sees movement, then determine if that movement is caused by proper motion, i.e. the star is simply moving across the sky, or to see if there's a binary there, and we're actually able to see both stars that make up that binary, or even a tertiary system. So then I obviously took this and did some Googling, and this is turns out to be data report number 2. Gaia is the name of the satellite and the satellite imaging program. It's also a goddess, a Greek goddess too as well, I believe is where the name came from. But the whole program dumped, I think they're on their 3rd release of data. We're talking about millions of lines of information. They had a data release 1 and data release 2 apparently contain information about this star. That's why it's called DR2. And then this is the Gaia, again, if that's how you pronounce it, this is the Gaia index number assigned to that particular star. And if you're familiar with a program called, if I can find it, it's a website it's a CDS portal where you can go to Sinbad and all these other databases online. I believe this is run by a university in France, if I'm not mistaken, but I can just do a basic search. And so you can see where I started searching for different names associated with this star. And what I ended up coming up with was this right here. And the Sinbad program will call up imagery. And sure enough, this is what it came up with, was this right here. And you'll see that that's our star in question. Notice how it's more in line with these 2 stars here versus going back to my imagery. There's the image, the background image, and then after seeing the proper motion in my image, you can see that these 2 stars, if you want to call them pointers, an extended line between the stars actually passes to the left of our target star right there. So again, here's I'm going to go back to their imagery. Here's pointer stars. It's almost a straight line. Our target star is right on that extended line, but then in my image, it's clearly passed on the other side of the extended line from these 2 pointers. And the same thing with the Sinbad imagery. Our question star is right on, if not just slightly left, of a line that extends to these 2 pointer stars. So again, that tells me we've got something here. So I went back and did a little bit of digging around. By the way, I'm not filming my tabs up at the top. I'm just filming the window itself at each of these. So let me go to a folder that contains sorry about that, and possible dwarf star. And here's some information. Well, let's do this. Just go through a couple things. So here's some information that the Sinbad program has on that particular star. You know, stars can have multiple names based on a name given to it because it's a visible star and the ancients a long time ago named it, or it could be given a name based on its position within a catalog. For example, M42, M31, M51, M1, for example. But here is another name for that star, G44-23. And this popped up in the Sinbad catalog, if you will, and it's a high proper motion star. And it also is found in a catalog of dwarf stars with high proper motion. So I haven't finished digging into that completely yet, but I suspect that not only, well, I know it's a high proper motion star, but I suspect it's a high proper dwarf star. And if we go back to some of the imagery, again, this is another map of that region with that dwarf star right there. These are all stars with proper motion. And this arrow, the length of the arrow represents the velocity, if you will, that proper motion, and the arrow and the direction of the arrow signifies the direction of that proper motion. This is again, Neowise. We hear about comets being discovered using this program, but also Neowise program has also been used to find dwarf stars. If you look at this thing, it's got a little bit of a red tint. It may be a white dwarf. These look more reddish, so maybe it's a white dwarf. But I'll do some more digging around on that to figure out exactly what kind of star that is. So let me get out of this, close that, and again, we're back to that. And let's go to, again, my worldwide telescope imagery and look at the motion of this thing. Now, I haven't scanned my whole image. I stopped here when I saw that movement. I quit scanning the rest of this because I'm not even sure. I don't think I've imaged the intended asteroid, but I certainly have captured a star with some pretty good proper motion here, which is pretty neat. So I wanted to show you that. A lot of great discoveries out there happen on accident, and certainly this was an accident. I'm not taking credit for discovering this dwarf star, certainly, but it's like imaging Pluto or any distant object for the first time. There's a little bit of elation involved and excitement, and I wanted to share that with you. All right, so if you got any questions, feel free to post them below. And if you've liked this video and any of the others on my channel, please subscribe. And I enjoy answering questions, and I'd love to hear them from you and or any comments. Have a good one. Bye.